Okay, beginning this experiment, I'm starting with water at about 60 degrees Celsius. Okay, and we've measured out approximately 100 milliliters of the 60 degrees Celsius water. I will be adding ice cubes to the mix. Okay, adding ice. I will be taking the temperature every 20 seconds. Okay, so I've hit about 4 degrees Celsius at about the 200-second interval. Removing the ice. Okay, after the ice has been removed, I'm showing it about 3 degrees Celsius. And next I'm going to carefully measure exactly how much water is in the cup. Okay, so there's the first 100. I've still got a little bit to go, so I'm just going to dump this out and pour in the rest and measure that. Okay, so we had the full 100 milliliters, and then we also have up to 64.5, so 164.5 milliliters of total water after the ice cubes have melted. Okay, for explaining my calculations, I did actually start out at a measured of 57 degrees Celsius, and I recorded the temperature every 20 seconds until I got down to 3 degrees Celsius. So when I was done, originally I had 100 milliliters. There's the temperature, and I found the final volume, which is a total of 164.5 milliliters, 3 degrees. I recorded everything in the data table, and since we know that pure water has a density of 1 gram per milliliter, then just an easy conversion. The hot water mass obviously is 100 grams. The total water mass is the same as up here, so it'd be 164.5. The melt water, which is just the difference between the two, is 64.5. Hot water temperature change, it started, the final was 3 degrees Celsius minus the initial 57, so we get negative 54. In the melt water, the final was 3 degrees Celsius, the initial was 0, so 3. Heat lost by water, so we use this equation here, Q equals mc delta T, M mass, C specific heat, and delta T temperature final minus temperature initial. We also want to keep in mind that in a closed system, you take all the energies, Q1, Q2, Q3, so on and so forth, equals 0. So I did the calculations over here for Q1. The mass, the water was 100 grams. Specific heat, 4.18 joules per gram times Celsius. And then the change in temperature was negative 54 degrees. Calculate this, and it gives a total of negative 22,572 joules. I recorded that over here because it does want it in joules, and I use 3 decimal places. Then Q2, 64.5 grams times 4.18 times 3 equals 808.83. Again, record that over here, 3 decimal places. And then Q3. Now this is for the ice itself. This is essentially before it melts. It is 64.5 grams total of the ice, because that is what was used to drop the temperature down to 3. So that'd be 64.5 times the heat of fusion. So now we just add everything together. I did convert all the joules here to kilojoules. So negative 22.57 plus 0.81 plus the Q3 was 64.5 times the heat fusion. We just do the math on this, move everything over here, then divide 21.76 by 64.5, and you get 0.337 kilojoules per gram. But the answer wants it in kilojoules per mole. So We come up here. Water has a molar mass of 18.015 grams per mole. Just multiply that by the 337 kilojoules per gram, and you get 6.071 kilojoules per mole. That'd be your answer.